Okay, so hello everyone. Well, first of all, thanks for inviting me. It's always nice to be present, especially at the first instance for new conference. So I'm really happy to be here. I have another CNCF project to introduce to you now, which is Parsec, the platform abstraction for security. So let me introduce myself. My name is Paul. I'm here from ARM, where I work as a solutions architect based in Cambridge, UK. I am one of the Parsec project maintainers, and I'm a tech lead for ARM's contributions into this project. You can find me on both the CNCF and the CCC Slack workspaces. I'm very happy to discuss today's content in further detail, or indeed respond to any questions that we don't get time for in the short session today. This is a lightning talk, so I'm just going to give a very brief overview of motivation behind Parsec. Why does it exist? What problem is it solving? I'll give a very high-level architectural view and perhaps also explore some of the intersection between Parsec and confidential computing. Okay, so let's begin. Parsec short for the platform abstraction for security. What does that mean? Why do we need that? We are used to running applications in the cloud, and the tools and techniques that we use for doing that are well established and understood. But there are some very good reasons why we might want to bring some of these workloads out of the cloud and run them at the edge, where they can be closer to endpoint devices that are generating the data that our applications are processing. So what if we want to migrate an application from cloud to edge? We immediately encounter two problems. The first is that we're now in a very different threat environment. Our edge devices might be exposed to threats that don't exist in a managed cloud, and we want the best possible protection for private assets such as keys, and that's almost certainly going to mean that we want some sort of hardware protection for those assets. But the second problem is that we have a diversity of platforms to consider, not just in terms of operating system and CPU architecture, but also different kinds of roots of trust and hardware facilities for secure storage. We might have access to trusted platform modules, for example. Hardware security modules might be available. We could have some other kind of secure element. We could have something that's firmware or software based, such as a secure key storage service or a cryptographic service running in a trusted execution environment. But whatever we have, our applications are going to want to consume these features. What we don't want is for all of our code to be tightly coupled to these systems. Not only can it be hard to learn how to use and consume them actually, but also the code's not going to be portable. So the goal is to retain a portable and cloud-native solution for applications, but still getting access to these essential but highly variable hardware security features. And that's where Parsec comes in. So Parsec is a public open source software project in CNCF Sandbox. It's a software service. It bundles with it all of that specialized knowledge that's needed to make use of these hardware security features that we find on the various platforms. Parsec then just takes care of the complexity of consuming them, and it exposes upwards a flexible API contract that can then be adapted into whatever programming language we want to use, giving us APIs that are portable, convenient to use, multi-tenant where necessary, and therefore giving us a cloud-native experience for application programming and deployment at the edge using the best available hardware security we have, but without tight coupling and without specialized knowledge. So that's the problem space, really. We'll take a quick look at the anatomy of Parsec now to see how it addresses that need. So a lightning tour of Parsec architecture. Parsec's essentially all host local. So everything you see here, think of it as running on a single node image with a rich OS like Linux, and including whatever applications and services the deployment needs. But everything's local. There's no network traffic here, at least as far as Parsec is concerned. Parsec runs as a software service, a daemon. It's in user space. Its job is to represent whatever hardware security facilities are available in the host, be that a TPM or an HSM or secure element or something else as we saw earlier. And Parsec represents those facilities and then surfaces a completely portable and uniform API upwards to applications. That API is all based on underlying contracts that are derived from Platform Security Architecture, or PSA. A PSA is an IoT industry standard for best practices in security. It includes functional API suites for things like key management and cryptography, storage and attestation. These PSA contracts represent the core of communication with the Parsec service, although Parsec is concentrating on key management and cryptography currently. The service itself is written in Rust. Rust is just the perfect language for Parsec. It gives us leanness, great performance, but it also gives us great safety and security guarantees as well. Applications consume Parsec's security services through a client library in the programming language of their choice. But Parsec is not a C API, like others you might encounter. Parsec uses protobuf contracts and a wire protocol that can be skinned into any programming language we like in a way that's ergonomic and sensible and fluent for developers using that language. The Parsec service itself has a front-end listener which receives API requests from applications. It has some access control logic and brokering logic that it uses in multi-tenant scenarios to keep applications hygienically separated from each other. And then finally, over there, the back end, it has these so-called provider modules. And this is where we isolate all of the complexity and all of the hardware-specific code for talking to those TPMs, HSMs, and so forth. So it becomes a totally fluent, portable experience for developers on the application side in whatever language they want to use. If you're familiar with the landscape of security APIs, then this slide might help you to understand where Parsec sits relative to those and why it confers some advantages. One question that often gets asked is why applications wouldn't just use a more popular, a more established CS11, for example. Well, Parsec can talk through all of these interfaces for you, and because the Parsec service is all in Rust, it can interface with C functions quite easily and through a limited number of carefully audited code points. But this avoids the need to consume those C functions into Go or Python or Java or whatever language you actually want to use. Parsec can also interface natively with other security APIs like TPM 2.0, CryptoAuthLib, for example, and it can do so without using PKCS11 as a bridge or a shim. And this improves fidelity, and it actually avoids some of the pitfalls and some of the behavioral quirks that tend to show up if you're using a lot of different PKCS11 libraries and shims. And then ultimately, Parsec is giving you a simpler API at the upper edge. It's designed to be easier to consume than some of these more specialized APIs. And if you couple that simplified dev experience with a client identity management mechanism as well, something that can handle multiple workloads for you and keep them separated, then hopefully you can see that you're gaining something by consuming Parsec up here at a higher level rather than APIs down at the bottom. Logo Cloud, quick look at who's involved with Parsec. Parsec's a public open source project, part of the CNCF Sandbox. It's very collaborative. It was seeded into GitHub originally by ARM and Docker. ARM is still contributing regularly. And we have this growing number of contributors, integrators, and innovators now working either on Parsec or with Parsec. We're seeing integrations with other open source projects like SPIFFE and Spire. We're seeing commercial use in production with products like Pelion. And since it became a CNCF project last year, we've seen steady growth and interest, and it's being adopted into Linux distros as well. It's packaged for OpenSUSE, Fedora so far, and we have recipes for Parsec in the Yocto project also for embedded Linux. So how is Parsec relevant to confidential computing? If we take the simplest and most general view of Parsec and Parsec usage, then it basically looks like this. Parsec sitting in between applications in rich user space and some kind of platform-specific root of trust or secure storage technology. And this is on all platforms, whether or not they support any kind of secure enclave or trusted execution technology. But if we do bring enclaves and Ts into the picture, then we can start to explore how this model might adapt to that kind of environment, and then perhaps even support some new use cases there. I already hinted actually on the earlier slides that a software module in a T could enrich Parsec by supporting some of its functions in a confidential space. Parsec can already be used with software services running in a T. We've seen Parsec working with T-based virtual HSMs and TPMs, for example. But that's really the T just supporting Parsec's functionality, if you like. But if we have a situation like this, where there are other confidential workloads also deployed into the same host, where we have Parsec as a secure backend in the T as well, then this is where things potentially get more interesting, because we can start to think about the interactions between Parsec's backend inside the T and the other workloads that are also there. And there could be some use cases we can enable here, I think, where Parsec is helping these rich applications outside of the T to transact perhaps key management or even just some raw blob storage management using those high-level interfaces in any programming language, and then have that be a front end for some key sharing or data sharing of some kind between the confidential workloads. And then we also have the option of making use of hardware protected encryption or storage outside of the T, maybe for some data at rest scenarios as well. But really the overriding message for today, I think, is that this is one thing we want to explore, and it's one of the reasons why I wanted to bring Parsec here today. I think this is exactly the right audience to be able to look at this project and maybe identify how it could be used in confidential compute environments. And we can let our imaginations take flight a little here, not thinking necessarily about the functionality of Parsec that exists now, today, but also about how it could evolve, possibly, and adapt. So suggestions, use cases, and potential requirements are certainly extremely welcome. Okay, finishing up, if this presentation has intrigued you about Parsec, the code is all there on GitHub. There is also an online book with quite a wealth of documentation about the project, along with API specs, published security threat models, and lots of details about how things work internally. We're a growing community and a welcoming community. Anybody is welcome to join. Lots of community resources there, also on GitHub, including meeting minutes, presentations. There's a Slack channel in CNCF. There is a weekly meeting, all of which is open and public for anyone to join. So that's it. Let me end there, and I will hand over to our next presenter. Thank you.